Good day, boys and girls. So this video is one that I really wish I didn't even have to make, but I'm optimistic that somebody's going to help me out. I'm actually appealing to help from somebody that has some experience with these pumps and has some idea what's going on. Basically, bottom line, my problem is I'm getting water into the motor canister. I've got two pumps here. One's taken apart, one's not. So here's the pump. Electricity connects here. Water comes out of here. The motor is set in here. And of course it's got its magnet, case, whatever. So it's in here. I got a couple of O-rings here. And that slides down into that canister. So in the process of operating, I'm getting water leaking down into my motor, and at that point it shorts out and burns the wire. Even though I have a fuse in line, it burns the wire on the brush. I'll show you kind of what's... Here are the two brushes that were in play. Obviously wet at this point, but you can see it just fried that wire right off. This one's probably no good either, but anyway. So rather than blowing the fuse, I guess that's a lighter wire, so took it out. Obviously, pump stops working. Now, I've been round and round and done some different tests, and some tests passed, but the ultimate test of putting it in the well and pumping water failed. So I'm going to just kind of ramble and go through things that I've tried and things that I thought and whatnot. So bear with me as I just ramble on. I'm kind of in an emergency situation because I've been without the ability to pump water now for about 20 days. So I've got about 5 days left of water on site. And then I cannot stay here at my home any longer. I have to go somewhere else if I want water. So forgive me if I seem a little impatient, a little rushed, and the editing is not what it could be. All right, so first thing to be said, this was a new cable. This is a new cable for the most part. The cable that had been in service for the past 7 years was starting to deteriorate a little bit here. There's two pieces of rubber, two boots in here. One is a little bit smaller than the other. So you put this boot on, then this boot on, and then the wires and whatnot. And this is what makes the seal for the wire. Well, the other boot, which is a bit older, this was starting to deteriorate a little bit. So I thought, okay, that's the source of my water problem. So I put some kind of all-purpose caulk type sealant. Here we call, in Brazil we call it fixa tudo, which means fix everything. So, and it did well. It maintained elastic, it sealed, it did a good job, I guess. So in the process of, trying that out, it failed again. But something I noticed in that failure was that I was not getting a good, solid connection. And how this works is, got a little flat area there. This plugs in, and you can see right away that this raised lip of the boot gets compressed all the way down onto this top edge. And it gets compressed that way by this, I'm going to call it a compression fitting because that's what's happening. So as you screw that down, it pushes that down. However, that's not as easy as it seems because you want to have this very tight to this also. So in order to even facilitate doing that, you have to lubricate this in doing that to make that happen. So when I removed the pump, after I had fixed these areas that I thought was leaking, I noticed that I could actually pull the cable loose even though I thought it was connected. That tells me this connection may not have been secure. So in the process of wrestling with that, I realized that I wasn't ever able to get it securely in there with this screwed down and not be able to pull it off. So I'm thinking that the threads might have been a little shallow because they're not very deep threads anyway. I don't know if you can see that, but these things are very shallow threads. So, thought my boot had been compromised. So then I came to, I'll call it my backup cable because it came with my backup pump that I've never used. So that presented me with a different challenge in that now I had to splice in my wire because for some reason this pump came with the boot already assembled on about 1 meter stretch of wire. So I got some, I'm going to call it waterproofing tape. Really, it's a 3M product. We'll call it high-end electrical tape that fuses to itself. And so anyway, I mended the wire. I put this tape on, submersed it in water for several hours, felt comfortable that it was secure my connection, so off we go. Spliced it onto my main cable that goes down to my well, and this is 30 meters. We're 30 meters of cable, that's how far down the well is, or how far down the pump is in the well. So I do all of this, I put it back in the well, new connector, new boot, and lubricate it. Pay real close attention to how it's connected and fastened into this, how this, lubricate and tighten it down. Couldn't remove it. Felt, everything was real flush all the way down to the canister top. Life was good. And it worked. It worked for, let's say, 20 minutes. It was pumping a weak volume though, and I'll get to that in a minute. So I noticed that the volume was pretty weak, but it was pumping. So closed off the valve at the pump site and gave it some time to pump up to the intermediate station, 70 meters in monomeric height away. Waited a few hours just to see if it's going to do anything. Went back down and pump's not pumping water. Pulled the pump out of the well, pump's got water in it again. At this time I was very careful in disassembling it because I wanted to see if water was getting in here. And it was, we'll call it moist around the edges, but not wet. So even though I felt like this was my source of leaking, I might have to rethink that. Now, in addition to water getting in, when I went to disassemble the pump, normally when you go to pull this section from the canister, here, when you go to pull those things apart, it takes a lot of force. This particular time, as soon as I got those screws out of here, these screws here, as soon as I start taking these out, this pump's wanting to rise. It's got force underneath it, which makes sense because if these are truly sealed, these bearings are sealed, not bearings, sorry. If these O-rings are sealed, I had air in the canister from when I put it together. And then water gets in there, it displaces the air and creates a pressure. Okay, so that made sense. It was so much pressure in here that it literally forced the pump section and the motor out of the canister. And the force was so great while it was still sealed that you can see where it has distorted and even broken one of the edges here. There was so much upward force on the screws that were here that it damaged the canister, which is pretty thick. I mean, this is rugged plastic. So that tells me that these O-rings are good. Okay? At least I'm assuming so, because they was holding back a lot of pressure. So I'm assuming they're good. So water then is getting in somewhere between here and here and somewhere on the inside of these O-rings, right? Because it's not getting in between the O-rings in the canister. At least I'm assuming so. So we remove this and we see we have 3 little grommets here that go around these little securing screws. And down in this hole are some more screws that allow you to take the pump body, or separate this part again from this part. So that's what these screws are down in there. So is that a possibility that water's getting in there? Maybe. I don't know. That seems kind of odd, but possible. Not sure where it goes after it gets through there. I would assume it comes into, yeah, that lines up and that lines up those holes. Now, another observation that I made was there wasn't a lot of water in the canister, only, we'll call it an inch, or like 4 centimeters of water in the bottom of the canister. Enough to wet these bearings, but not really enough to get up here. So, and these bearings seem okay. But then again, if it was leaking from these holes, it wouldn't have affected those bearings anyway, as the water level only rose up to here anyway. So, possible that that's, a source of infiltration. Now moving on. Again, this is sealed, okay? So the other point of entry would be possible, I guess. If this is sealed, and we notice that slides down through there, and what I'm looking at here is this lip where it's white around the black. Okay, so logically, if this part was filling up with water, water could then get between here and here. However, like I said, this wasn't soaked. It was damp around the edges, but this was not soaked. I would think this would be soaked. There would actually be water sitting in there. This can be removed, and all it does is pull these 2 wires out. So, again, if it was leaking through here, this would be where it was entering the chamber. It would be coming from where the wires are, not these holes here. Alright, so possibility number 2, maybe. Number 3, I've learned that reading on some forums here that in some of the models of the 9000 series, which is what this is, when the diaphragms start to go, they allow water to pass through. And I'm assuming it would pass through to these bearings. It would come through the bearings, come through this area in here where the actual motor connects to the diaphragm itself. Or maybe, this lip here, because this, you could separate this. Had I loosened these screws, you can take this apart. So, and in the diaphragm, there's little nipples and springs and whatnot. And if those are failing and allowing water to pass through and get into the motor, and even here we got some possibilities there, although that looks very similar to that, almost as if that's an alternate wire location just on the other side of the pump. Kind of odd, not sure what that is. If you can see those holes. So that goes back to what I said earlier about the pump being weak. If the diaphragm's starting to fail, then, and it hasn't completely failed, then you're going to start losing pressure. So if my diaphragm is failing, leaking, but then again not leaking too much because we had a small amount of water in the chamber, in this canister. You know, it's not full of water, just a little bit of water and enough to get into the brushes and cause them to short out and to have electrical failure. And at that point, I guess water stops entering. So logically, and another thing that I had done, let me back up. Once I got everything together, I had fixed my wire, I had put on my new connector, I submersed it in water. I couldn't run it up here at the house because it's on a different system. It's 24 volts, not 12. I didn't run it. I just submerged it, left it submerged overnight. No water in the canister. I took it down, put it in service at the well. It worked. So, logically, when it starts pumping, maybe it lets a little bit of water in through the diaphragm, and then when it electrically shorts out, the diaphragm is no longer moving. Maybe it's resting in a sealed state, and no more water comes in. I don't know. I'm at a loss, but I need to solve it. If anybody's got any experience in this and in wrestling with these pumps or submersible pumps in general, any insight here I'd appreciate, because I'm stumped. Right now I'm on the internet searching forums and stuff, and there's not a lot out there. There's some things. Some of the conversations I've heard and read are back in 2010, and one of the posters commented that when the diaphragms failed or started to fail, they would allow water into the motor chamber in older models. But since then, Shurflo had changed and allowed a vent to vent that water out somewhere else. Well, I don't know where that would be in this model. Now and that was 2010 post. So if they're saying newer models, I'm guessing they're talking about 2010 models. Or, can't be any newer than that because the form wasn't there. So this is the intake, right? This is how it gets its water in. It comes through the screen and into these places. So, is it possible when they talk about venting, is it venting somewhere else above these O-rings? Possible. Not sure. I'm going to take this apart and investigate a little bit further. Maybe you can see better. So yeah, this is where the intake is again, and then maybe one of these is a vent. If it does fail, it lets it out. I don't know. I have to tear it apart further and get into that. But so anyway, a poster had made this comment that the newer models had some venting to allow water that when the diaphragm failed, to let it out above these O-rings so that it wouldn't get into the motor chamber. Is that what I have? I don't know. So, odd, but I need to solve it. And of course, these things are, unbelievably expensive. And I don't want to put a new one. Right now I got two of them that they get water in. And again, that's kind of odd. That suggests this. That suggests the common point, which is the connector. However, it is very possible that it's a coincidence in that this pump got water in it because the connector wasn't seated. And then I get the seating problem fixed on this pump, but it's got a diaphragm failure. Who knows? This pump is 4 years older than this pump. And this pump hasn't seen a lot of service. This pump worked continuously until it didn't, in which I changed the brushes, made a video on that, put it back in service, and it continued to work, and then it failed. And here's a really nasty part of that story, is when it failed, I was assuming it was brushes. So I was getting ready to leave on an extended trip, and it happened to fail right before I was leaving. And I had some folks staying here looking after the house, so I had to put my backup into service, which I did. So I took this pump out and just set it aside, assuming that I would need to change the brushes, so that when this pump failed and had water in it, I'm thinking, oh, okay, well, I'll go, put some brushes in this one and put it into service. When I go to change the brushes in this pump has water in it. Water's been in there for 2.5 years. So I took the motor, cleaned it out, and obviously, the bearings are no good inside of this pump. So I'll be changing those soon. First, I've got to make a tool that I can pull these bearings, because all the bearing pullers I can find won't fit into this clearance. So a little bit tight for them. So we'll be making a video on that too, as we make the tool and pull that bearing loose. And the one that sat for 3 years, it's both bearings. It's the topper and the lower and the upper bearings that are bad. So there's a bearing up here too. I'm gonna have to change in that one, which I'm not sure how to get that out yet. So anyway, bad story there. So that motor's set full of water for 2.5 years. Motor's still good though. Just need to, I cleaned up the copper parts, and obviously the bearings are in bad shape, but I think the motor still works. So there's my plea for help. Let me know. Send me some comments, send me some information, send me some links to videos and forums and other information to help me solve this problem. Thanks for watching, guys.